Okay, so today we're going to be talking about lines and equations. Um, Hopefully you already know a little bit on lines and equations, but if not, that's okay. Okay, so first off, initially there's the XY coordinate system. It's also called the Cartesian coordinate system. It's just your regular graph, like everybody knows this graph. It's like got two lines perpendicular. Um, there are four parts, four quadrants to this. This is quadrant one. It kind of goes like this way, counterclockwise. This is quadrant two. This is quadrant three. And then this is the last quadrant, quadrant four. So probably you guys should memorize this. It counterclockwise counts one, two, three, four. And that's like, so this would be the first quadrant. This is the fourth quadrant, second quadrant, and third quadrant. Okay. Um, the horizontal line is called the x-axis. So this line right here is called the x-axis. And then this line right here is called the y-axis. So a normal one would be drawn like this, this. This can be labeled the y-axis. This is labeled x-axis and arrows because it's continuous. And then again, this is the first quadrant, second, third, fourth quadrant. And then the midpoint, the point 0, 0 right here, that's called the origin. So just some terminology there. Quadrants, origin, x, y axis. Okay. An ordered pair is just basically a point where you have the x-axis and then comma y-axis or y point and then parentheses. So this is the value of the x here, and then the value of the y goes next to it. So 0.34 is where the x is equal to 3 and the y is equal to 4. So this would be 0.34. Just some basic stuff. Also, you don't really have to know this, just like fun trivia. The x-coordinate is also called the abscissa. The y-coordinate is called the ordinate. You don't really need to know that. Okay. So this is an important formula. It tells you the distance between 2 points, and it's derived from basically Pythagorean theorem. So if you're trying to find the distance between point xx, x1, 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 y1, and point x2, y2, you basically just draw a right triangle, and then you know this leg right here because it's just a difference in the y's, and then you know this leg right here because it's just a difference in the x. So let me just let's try to draw this a little bit. Alright, so you're trying to find the distance between this point and this point. Okay. So you know this right here, the x, we'll do that in this color. You know this, okay. You know this point right here because it's just this distance here. And this distance right here is basically just this y minus this y, because this y is right here. So let's say this y was 4, and then this y right here would be negative 2, so then the distance would be 6. I don't know if I explained that really well, but so it's just so you don't even have to know how to derive it, you can just memorize the formula. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So you have to keep it so that if you use x2 first, then you have to use y2 first. So it's distance between points x2 and y2 and x1 and y1 is equal to the square root of, so let's say I use x1, then I'll use x1 minus x2 squared plus, and then since I used x1 here, I have to use y1 minus y2 squared. So that's how to find the distance between 2 points. It's just the difference between the x points and the difference between the y points. And you have to have it so that if you subtract this x from this x, you have to subtract this y from this y. So just memorize that formula. And if you can think about it well enough, it's just basically the Pythagorean theorem between 2 points. Okay, so find the distance between 0.31 and 6.5. I'll let you guys see the formula there. So it's just basically the difference between the x points and the difference between the y points. And then you take the square of those and then take the square root. Oh, nice. AOPS. Okay, I'll explain this one, but nice job. You got it. It's 5. So difference between the x points. So this one is 3 minus this one is 6. And then you square that. And you add that to difference between the y's, 1 and 5. And you square that. And you take the square root of that. And then this equals the square root of, so 3 minus 6 is 3, 3 squared is 9, plus 1 minus 5 is 4, 4 squared is 16, and then that's the square root of 25. So the answer is 5. So again, the distance formula is just basically the difference between the x's, which is 3 and 6, add it squared plus the difference between the y's is 1 and 5. And then if you subtract 3 from 6, then you have to subtract 1 from 5. And just go from there. Okay, I think there's another one. So like here, x1 is 3, x2 is 6, y1 is 1, and then y2 is 5. So it's just difference in the x points and the difference in the y's. And then take the square of that and then square root. Note this is incorrect. If you can't have it so that you subtract 3 from 6 and then 5 from 1 or something like that. Okay, I think there's more on this later. So we'll talk about this. Okay, so this is one really important point. It's called the midpoint formula. Math counts usually tests on this a lot, actually. So the coordinates of the midpoint of a line segment x1, y1, and x2, y2 is just basically you sum up the x's and you divide by 2, and then you sum up the y's and then you divide by 2, and then that's your point. So like point 1, 2, and point 3, 6. If someone was like, find the midpoint between the line segment that connects 1, 2, and 3, 6. So I add up the x-axis, which is 3 plus 1, and then I divide that by 2, so it's 2, so 4 divided by 2. And I add up the y's, which is 6 and 2, which is 8, and then divide by 2 is 4. So then the midpoint is 2, 4. So you just add up the x's, divide by 2, and then add up the y's, and then divide by 2. So this is something actually from math counts. So find the coordinates of the midpoint of the line segment between 5, 8, and 3 and 14. All right, nice job to these guys who got it down here. Basically, you just add up the x points, which is 5 and 3, that's 8. And then you divide by 2. And then you add up the y's, which is 8 and 14, which is 22. And you divide by 2, so you get your point 411. Right, okay. Okay. Next thing we'll talk about is lines in their equations in the coordinate plane. So there's actually 3 types of ways. I don't think there's 2 listed here, but there's 3 types. Okay. So the standard form is of any line is this is for lines only, ax plus by plus c equals 0. So this is just like the standard equation for any line. So any line can be written like this. I like to use the y-intercept equation, I think that's called, which is y equals ax plus b. This is another way you could write a line. So basically you just move x to the other side and divide by b. So I usually use this one. I think this one's a little bit easier for some people, but this works too. Okay. So let's try this point. For what value k will the line with the equation kx plus 3y equals 20 contain the point 7, 2? So another like quick thing, if a line contains a point, if you plug it in, then the equation is valid. So if you plug the point in for x and y, then the equation is valid. So just plug the points in and then solve for k. Probably be the best line of action. So you know the point is x, y. So plug and see what you get. Right, so nice. The correct answer is 2. Again, so points are done in x, y. So we know our point here, x is 7 and then y is 2. So it's basically 7x plus 3. Oh, sorry. When we plug x in, we get 7k. And then we plug y in, which is 2. So 3 times 2 is 6 equals 20. And then we solve for k, which is equal to 2. So this is point x, y. And then plug in x and y and solve for k. So it's 2. Okay. The y-intercept of this line is 1. What is the value of m? So if you actually, I'll let you guys try this, and if you guys no one gets it, I'll throw some hints out. Okay, actually, the y-intercept of a line is basically where the line hits the y-axis. So at that point, x is going to be equal to 0, and then the y-intercept is whatever this y is. So that's where this point is going to be, because x is going to equal 0, and then y is just going to be y. So in this case, it says the y-intercept is 1, so the point is 0, 1. Actually, this one's a little bit complicated, so I'll just go through it with you guys. I'll just work through it with you guys. Um, so it says the y-intercept is 1. So if it tells you the y-intercept, then you know the point is going to be 0, 1. Because at the y-intercept, at the place the point hits the y-axis, x is going to be 0 and y is going to be whatever it says it is, so it's 1. So 0, 1 is on this line. So you can plug in 0, 1. So x equals 0, so this whole thing doesn't matter anymore. And then y equals 1, so it's just m squared minus m minus 2 times 1. So if you times 1, it's still going to be the same. So it equals m plus 1. And then move everything over to the left-hand side. So it's m squared minus 2m minus 3 equals 0. And then here you have to solve the quadratic. And then you can solve the quadratic, but you can also factor it into m minus 3 times m plus 1 equals 0. And you get m equals 3 and negative 1. And then apparently negative 1 doesn't work, so m equals 3 is the answer. That one's a little bit harder. Sorry about that. Okay, so another form. So we already have like the y-intercept, y equals ax plus b. And we also have the other one, which is standard, which is ax plus by plus c equals 0. So this is standard. So a third type of equation to represent a line is called the point slope form. This is really helpful if the problem gives you a slope and it gives you a point. You can also use the y-intercept to solve it, but that's a little bit harder. This is like the easier way. So it's just y minus y1 equals m, which is the slope, multiplied by x minus x1. So it's just basically you plug in y1 and x1 because you have a point, and you plug in the slope because it gives you the slope, and it should give you an equation. So this is probably good to memorize. You don't have to though, because you can always use this. You can plug in points and then try to find the slope that way. So, or try to find b that way. Okay. Find a such that so that the point 3 comma a is on the graph of y equals 4x minus 14. You can use point slope, but you can also just plug it in, and I think that'd be easier, so you can go either way. So just see if you can get that. I think plugging in would be faster though. So just plug in 3 for x and then a for y, and then solve for a. Right, so the answer is -2. You can either use this, but I don't think it's too applicable, because you can just plug in, like, it's just a equals 4 times 3 minus 14, which is -2. Because basically we just plugged in 3 for x. Yeah, that used that too. Okay. Oh yeah, so this is what I use the most, or I used to use this the most. It's called the slope-intercept form. It's just y equals mx plus b. So you don't really need to memorize all those other forms. I think it helps like speed it up, but this form like pretty much encompasses them as well. So it's just y equals m is the slope, and then x plus b, and then b is going to be the y-intercept, because when x equals 0, it's the y-intercept, and when x equals 0, y equals b. So that's a way to think about it as well. Okay. So this is just basically saying find the slope of the equation y equals y 4y minus 3x equals 10. So find the slope of this. So you can try to put it back into this form and then see what m is. So basically just move x to the other side and then divide by whatever the coefficient of y is to find m. So try to get this one. Oh, sorry. Try to get this to look like this and see what m is, because m is the slope and it asks for the slope. Right, so the correct answer is 3/4. Nice job to these two. Um, Basically you're trying to get it back into this form, which has coefficient of y is 1, and this one's 4. So first we'll move x to the other side, so we get 4y equals 3x plus 10. And then since y's coefficient is 1, we have to get it to 1, so we divide everything by 4, so we get y equals 3/4 x plus 10 over 4. And then it asks for the slope, which is m, so we see it's 3/4, and it's a common fraction. So, okay, this one's pretty easy. Which of the quadrants in the coordinate plane contains no points of the graph of the equation y equals 3x plus 1? So, it should be not too hard. Right, so it's just the fourth. 1, 2, 3, 4. So nice job to you guys. So you see in the first quadrant there are points, second quadrant points, third quadrant. Only the fourth quadrant doesn't have any points. Okay. This is also pretty helpful. I don't think I ever remembered this, but it would have been good if I did. It's called the two-intercept form. So you can write the equation of a line if it just gives you two intercepts. So point B is going to be the y-intercept, and point A is going to be the x-intercept. So when it says intercept, like if you had 5 as the intercept, then you'd automatically know it's 0.05 if it's the y-intercept, because if it intersects the y-axis, then x is going to be 0. And if it intersects the x-axis, then y is going to be 0. So this is just the general equation. So x over the x-intercept, which is a, and if it should be given to you if you're using this, and then plus y over the y-intercept, which is b, so it's b, and then this is equal to 1. So that's the two-intercept form. So like if it says the x-intercept is 5 and the y-intercept is 3, find the equation, then you can just automatically go x-intercept is 5 plus y-intercept is 3 equals 1, and then you have your equation right there. Okay. So, okay, this one should be pretty easy. Well, what is the x-intercept of the function whose graph is shown as below? Well, the x-intercept is actually not 5. Right. That's -5. So nice job. Right, so the x-intercept is -5, and then the y-intercept is 3. So then, like, how about, what if the question was, what is the equation of the line? So write out the equation of the line for me. You can leave it in the fractional form. Right, so I think you left out the negative again, but it's just basically x over -5, and then plus y over the y-intercept, which is 3, that equals 1. And that's the equation. So it's just x over the x-intercept plus y over the y-intercept equals 1, and that's the equation. Okay. If okay, let's try this math counts problem. It's kind of like a 3-step, or more of like a 2-step problem. If a is the x-intercept, b is the y-intercept, and m is the slope of the line with the equation this, what is the value of a plus b plus m? So again, um, you probably should keep in mind that this is the equation of a line with the x-intercept of a and the y-intercept of b. That would help you solve this problem. Okay, so like as a little hint, remember um remember this equation right here? I'll write it. X over A plus Y over B equals 1. The A is the x-intercept and the Y is the A is the x-intercept and then the B is the y-intercept. So that kind of applies to our problem because so basically the x-intercept and the y-intercept are just given to you and all you have to do is find the slope. So you just have to find the slope of this equation. No, not 1. Right, so the correct answer is 13. Nice job. I think you got it in the end. Nice job to this guy too. Basically the x-intercept and the y-intercept are given to you as 4 and 12 because it's in the exact same format. So all you have to do is find the slope. So you can find the slope by putting it into slope-intercept form, or at least that's what I did. So it's just slope-intercept form is y equals ax plus b. And we're trying to get this to look like this. So first we move the x over. So we get y over 12 equals negative x over 4 plus 1. And then we multiply everything by 12 because coefficient of this is 1. So it's just y equals this multiplied by 12 is negative 3x plus 12. And then we see the slope is negative 3 plus the two intercepts, which is 4 and 12. And we get 13. So we know that A and B are the intercepts, and then just solve this for 12. Okay. Onwards. Okay. So if you guys didn't already know this, which you probably should have, the slope of a line is given by, it's basically called rise over run. So it's just how much it rises over how much it runs. So it's just slope, usually denoted as m, is equal to delta y, which is how much it rises, over delta x, which is how much it runs. So it's just basically the change in the y, which is how far y changes, which is, in this case, we'll just use y2 minus y1, over the change in x, so how much x changes, which is x2 minus x1. And then given that the point is x1, y1, and x2, y2. y2. So it's just subtract the y's over the difference in the x's. And then you see if we subtract this y from this y, we have to subtract this x from this x. We can also say it's y1 minus y2 over x1 over x2. But if you start with something in the front, you have to also have this something in the front in the x as well. Okay, so yeah, change in y is on the top and change in x is on the bottom. So don't forget about that. So this is really important. Start with the x and y values of one point and subtract the corresponding values of the other point. So you can't do y1 minus y2 over x2 over x1 because it just doesn't correlate like that. If you start with 2's in the front, you have to have 2's in the front for both of them, and then 1's in the back. Okay. So this is a good graph right here. You guys should know that anything that runs like this, anything that goes like this, Anything that runs like this has a positive slope, and anything that runs like this has a negative slope. So it's just like something you have to see enough for you guys for them to memorize. So anything, oops, um, anything that goes like this is gonna have a positive slope, and anything that goes like this is gonna have a negative slope. So for example, if I were to draw, so this is my coordinate, oh my gosh, coordinate plane. If I were to draw this point right here, does it have a positive or a negative slope? Right, okay. So it has a positive slope, right? And if you drew it like that, that's a negative slope. Okay. Okay. Parallel lines have the same slope. So that's just something you should memorize as well. Uh, if two lines are parallel, they'll always have the same slope. So any two lines, if they're parallel, they have the same slope. Two lines, perpendicular lines, have slopes that are negative inverses of each other. So let's say I had a line y equals 2x plus 1. Then the slope is going to be you flip it, which is 1/2, and you turn it negative. So the perpendicular line is going to have a slope of negative 1/2. So you can also think of it as their products. The products of the two slopes have a product of -1. That works too. I usually just think of just flipping it and then putting a negative sign in front of it. So like if the slope was -1/3, and then the question was, what is the slope of the perpendicular line? I flip it, it becomes 3, and then put a negative, so negative and negatives cancel out, so it's just 3. So it's just inverse and then negative. It's negative inverse. Okay, let's try this problem. Knowing that inverses, perpendicular lines are negative inverses, what is the slope of all lines perpendicular to the line given by the equation 3x plus 2y equals 1? Hmm. Right. So the correct answer is 2/3. Nice job. I don't know why nobody else has responded. That's okay. Um, so it's 2/3. So basically the slope is the negative inverse. So we find the slope first. So it's 2y equals negative. All right. Thanks. 2/3. Negative 3x plus 1. And then solve for y. Y equals -3 over 2x plus 1/2. And then so we know the slope of our current line is this. So the slope of the perpendicular line is you flip it, so you take the inverse, so it's 2/3, and then negative inverse, which is negative and negative, so it's positive. It cancels out. Okay. So let's try this one. Point 32 is on a line which is parallel to the line x minus 3y equals 7. What is the equation of the line? So as a little hint, just if it's parallel, it has the same slope, and then you have a slope and a point. So you can either use point slope formula, or you can just use y-intercept formula. That works too. Okay, that's close, but it's not correct, I think. Yeah. Okay, so just a little hint. First you set this line into the y-intercept form, so you get negative 3y. So I move the x over to negative x plus 7, and I divide by negative 3 on both sides, so you get y equals 1/3 x plus 7 over negative 7 over 3. So all you really need is, it says it's parallel to this line, so all you really need is the slope. So the slope's going to be the same. So now you have y equals 1/3 x plus b. And then you're trying to find b, and it says it gives you 0.32. So plug in 0.32 and solve for b, and it should give you the equation of the line that is parallel. Right, so b equals 1 in the end, because plug in 0.23, 1 over 3 times 3 plus b, and then you solve for b, and then b equals 1. Anyway, so I think we're just going to end class early a little bit. I think I covered all that I really wanted to cover. Anyways, so this is the last class. I'd appreciate it if you gave me some feedback on the forum, so I'll just determine if I start up another class at some later point in time. But anyway, thanks for coming, guys. This is the last class. Appreciate some feedback if you have it on my forum. Bye.